This is an assessment of the relationship between human activity and soil quality in Marin County, California. Human-induced soil degradation is a global issue that is increasing in rate. Reduced soil quality puts infrastructure at risk of damage by fire and erosion and poses an ecological threat to biodiversity. This graph shows the increasing rate of deforestation levels in the last 200 years. This is alarming because deforestation has a direct and indirect effect on soil health. Loss of forest due to deforestation increases the risk of soil erodibility and nutrient depletion. Construction near riverbanks has been found to increase soil erodibility, and inorganic farming depletes available nutrients in soil, which in turn impacts the stability of living organisms that directly and indirectly rely on healthy soil to survive. Moreover, research suggests that urbanization negatively impacts soil health by way of pollution and contamination as a result of improper disposal of waste. This leads us to our study area. Marin County is an urbanized area that is flanked by the Golden Gate National Recreation Area, one of the most popular national parks in the United States. This unique county, which is heavily urbanized to its east and pristinely protected to its west and south, offers an opportunity for us to try to correlate soil health to human activity by studying soil health in areas with a lot of human activity and areas without a lot of human activity. To determine the extent and severity of soil quality, our team hypothesized that there is a positive correlation between major human activity and degraded soil quality in Marin County. Our research questions focused on whether human disturbance adversely impacts soil quality, and if so, which soil characteristics are most impacted. Could this analysis inform future planning or restoration efforts? If our findings were significant, we could provide this information to places like Goga to use in management efforts, such as improving heavily eroded areas. We used 3 sets of data to inform our analysis. The National Land Cover Database provides nationwide data on land cover and land cover change with a 16-class legend based on a modified Anderson Level 2 classification system. The dataset allowed us to differentiate between canopy, residential, and commercial areas. Our second data set was data published and operated by USDA Natural Resources Conservation Service, NRCS. Our key focus was on soil erodibility, soil fire damage, and soil rutting, with the intention of finding a correlation between construction of highways, residential, and commercial spaces, and the quality of the soil based on those 3 characteristics. Finally, the third data set we used was provided by the Golden Gate National Recreation Area. This data set has information on the Goga territory, which comprises Marin, San Francisco, and San Mateo counties.
Here is our overall methods flowchart. We have raw data sets from land cover and soil characteristics. We then proceeded to either remove chart junk or use table joins. Then we use a geoprocessing tool called Cookie Cut. And then with the Marin County and land cover and Marin County soil characteristics, we then reclassified both of them. And then we used a fuzzy membership on land cover and soil characteristics to then use a spatial analysis. Here's an example of our kernel density map. Once we had all 3 databases together, we then reclassified the layers using kernel densities. Here you see roads, and now, boom, their density. A part of our methods was using a fuzzy overlay. To us, with characteristics such as hazard and susceptibility and potential. These were all relative to fuzzy logic, as in non-discrete. Our first map shows soil rutting. You can think of it as soil rotting, basically just poor soil. We can see that severe is most everywhere and does not have to do with human intensity, which is the purple layer. Here we see that areas of high human activity and high canopy cover are not prone to fire. We have some evidence of low human activity and modest forest cover are prone to forest fire, but that's about it. Our soil erosion hazard is also in the severe level. We have, once again, our human densities in the purple is not clearly relative to the largely red areas. This is our final map, and we ended up using layers from for the analysis, such as soil rutting hazard, Marin roads, erosion hazard off-road, and rivers. However, we have areas that are yellow, that are low susceptibility to soil degradation, right next to high human activity, and red areas that are entirely secluded and isolated from human activity. In conclusion, there are no strong correlation between human activity and soil quality. We can say that there are factors outside of human activity that affect soil quality. However, our map can potentially show for future planners and urban developers where soil quality might be susceptible to poor or erosion. And our future data sets would hopefully do a time study. Megan and Fernanda, we thank you so much for your support and education. We would like to thank Ben Sound for the music, and Goga, MRLC, and NRCS for the datasets.